Have you ever wished for more time in a day? Perhaps you've felt the relentless march of seconds, wishing you could just pause the world for a moment. We all know that feeling of time slipping through our fingers. Ironically, Earth is spinning faster, a subtle but significant change in its rotation. It's a phenomenon that's capturing the attention of scientists worldwide. And scientists warn we might soon experience the shortest day ever recorded. This isn't just a minor fluctuation, it could be a record-breaking event. This isn't science fiction, this is happening right now, based on meticulous observations and complex calculations. It's a real phenomenon measured in milliseconds, tiny fractions of a second that are usually imperceptible to us. But even such tiny changes can have big consequences. These seemingly insignificant shifts can ripple through various systems, affecting everything from our technology to our environment. Astrophysicists are on high alert, carefully monitoring the Earth's rotation and analyzing the data to understand the implications, predicting that July or August 2025 could set a new record for the shortest day. Mark your calendars, because this summer could be one for the history books in a way you might not expect. For billions of years, Earth's rotation has been slowing, a gradual deceleration that has shaped our planet's history. Mainly due to the moon's gravitational pull, the moon's influence acts like a brake, gently slowing our planet's spin over eons. Now, suddenly, it's speeding up, a surprising reversal of this long-term trend. What could be causing this unexpected acceleration? A major scientific surprise. This acceleration has left scientists scratching their heads, eager to understand the underlying mechanisms. Experts are racing to uncover the cause, employing cutting-edge technology and collaborative research efforts, searching deep within Earth's core, exploring the complex dynamics of our planet's hidden engine, and in the movements of its oceans and atmosphere. These vast systems play a crucial role in shaping our planet's rotation. We're about to explore how we measure time, delving into the fascinating world of atomic clocks and precise measurement techniques. What makes our planet spin, uncovering the fundamental forces that govern Earth's rotation, and why a few milliseconds matter. These tiny fractions of a second can have a surprisingly large impact on our technology and daily lives. Even the length of a day is part of a grand, ever-changing cosmic dance. It's a reminder that our planet is not an isolated entity, but rather an integral part of a vast and dynamic universe. At the heart of this fascinating discovery, working tirelessly to unravel the mysteries of our planet's rotation, are dedicated scientists like astrophysicist Graham Jones. He was among the first to predict the coming shortest day. Jones meticulously analyzed precise planetary data, sifting through complex information to identify subtle shifts in Earth's rotational speed. His work involves countless hours poring over datasets, searching for patterns that might elude the casual observer. Jones and his colleagues rely on incredibly precise instruments, namely atomic clocks. These sophisticated devices are so accurate that they measure time by the vibrations of atoms, the most consistent phenomenon known to science. This level of precision is essential for detecting the minute variations in Earth's rotation. They use these atomic clocks to compare Earth's rotation with the fixed positions of distant stars. This comparison allows them to identify even the slightest changes in our planet's spin. Another key figure in this research is Leonid Zotov from Moscow State University, a leading expert in geophysics. He was among the first to notice Earth's sudden acceleration in its rotation, a phenomenon that has puzzled scientists worldwide. Zotov has highlighted just how mysterious this speedup is, emphasizing the need for further investigation into the forces driving it. The underlying cause of this acceleration remains unknown, a perplexing enigma for the scientific community. Scientists are exploring various theories, with some suggesting that the answer lies in core movements deep within the Earth. Others propose that shifts in global weather patterns and climate change could be contributing factors. These scientists are not working in isolation. They collaborate globally, forming an international network of researchers. They are sharing data from satellites, observatories, and research institutions around the world. This collaborative effort is essential to piece together the complex puzzle of Earth's rotation. Their work is not just interesting, it's crucial. It's vital, not just for advancing our scientific understanding of the planet, but also for keeping our increasingly technology-dependent world in sync, ensuring the accuracy of everything from GPS navigation to high-frequency trading. They're the detectives of time, meticulously investigating every fluctuation and anomaly. They are ensuring our clocks, and therefore our technology, accurately match the planet's ever so slightly variable rhythm. The world is watching their predictions closely, eager to see if their findings hold true. The anticipation is building as we approach a possible new record for the shortest day, a milestone that could have far-reaching implications. Ultimately, their findings could fundamentally change how we understand time itself and its relationship to our planet. We think of a day as 24 hours, a neat and tidy package of time that governs our schedules, our sleep cycles, and even our very lives. It's the fundamental unit by which we measure our existence, from the moment we wake up to the time we drift off to sleep. But what if I told you that this seemingly immutable constant is actually far more fluid and dynamic than we ever imagined? What if the length of a day isn't as fixed as we believe? Because Earth's rotation isn't perfectly constant. It's not a smooth, unwavering spin like a perfectly balanced top. Instead, it's more like a slightly wobbly one, subject to a myriad of subtle influences that cause it to speed up and slow down in unpredictable ways. These variations, though minuscule, have profound implications for how we measure time and how we synchronize our lives with the natural world. Our ancestors relied on the sun's rhythm, the most obvious and readily available timekeeper. They tracked the sun's journey across the sky, marking the passage of time with sundials and other ingenious devices. For them, the day was defined by the sun's arc, a simple and reliable measure that dictated the rhythm of their daily lives. But today, we know the length of a day, measured with incredible precision using advanced technology, is not always the same. We've moved beyond the simple observations of our ancestors and delved into the intricate mechanics of our planet, uncovering the subtle forces that shape its rotation. Can fluctuate by milliseconds, tiny fractions of a second that might seem insignificant, but which accumulate over time and can have a noticeable impact on our carefully calibrated timekeeping systems. These seemingly imperceptible variations are a testament to the complex and dynamic nature of our planet. Due to factors like the moon's pull, the celestial dance between our planet and its natural satellite exerts a constant gravitational tug, influencing the Earth's rotation and causing subtle variations in the length of the day. Ocean tides, the rhythmic rise and fall of the seas, are another significant factor. The movement of these vast bodies of water creates friction and exerts a subtle braking force on the Earth's rotation, contributing to the fluctuations in the length of the day. And atmospheric shifts. The ever-changing patterns of weather, the shifting winds, and the variations in atmospheric pressure all contribute to the complex interplay of forces that affect the Earth's rotation. Since the 1960s, scientists have defined a second using atomic clocks, incredibly precise instruments that rely on the consistent and predictable behavior of atoms to measure time with unparalleled accuracy. Based on the vibrations of cesium atoms, these clocks exploit the fundamental properties of matter to create a time standard that is far more stable and reliable than anything our ancestors could have imagined, creating a stable time standard. This standard allows us to measure the Earth's rotation with incredible precision and to detect even the slightest variations in the length of a day. We now track two times: universal time, UT1, based on Earth's rotation, a measure that reflects the actual spin of our planet and its relationship to the sun, and coordinated universal time, UTC, based on atomic clocks, a highly precise and stable timescale that serves as the foundation for global timekeeping. These two times slowly drift apart, a consequence of the Earth's irregular rotation and the unwavering precision of atomic clocks. Because Earth's spin is irregular, this irregularity is not just a scientific curiosity. It has real-world implications for everything from satellite navigation to high-frequency trading. Scientists like Jones and Zotoff use this drift to detect changes in Earth's speed, meticulously analyzing the discrepancies between UT1 and UTC to gain insights into the forces that are shaping our planet's rotation. The recent acceleration means our planet's natural clock is running faster than our atomic one, a phenomenon that has surprised and intrigued scientists around the world. Even tiny differences matter when it comes to keeping the world in sync. These seemingly insignificant variations can accumulate over time, potentially disrupting the delicate balance of our global timekeeping systems and requiring adjustments to ensure that everything runs smoothly. For ages, Earth's rotation was slowing, but in 2020, scientists saw a reversal. Earth started spinning faster. Days became shorter, with June 29, 2022, marking the shortest day ever recorded, 1.59 milliseconds less than usual. This wasn't a fluke. It was a sustained trend, with several near-record days following. The abruptness of this change shocked scientists, suggesting powerful short-term forces are at play. Researchers are now re-examining everything from the planet's core to its atmosphere for answers. The acceleration is faster than current models can explain. The mystery deepens as we approach the predicted new record. The reason why Earth is spinning faster remains one of science's biggest puzzles. Think of Earth like a spinning skater. When mass shifts, the spin changes. Movements in Earth's molten core can redistribute mass, speeding up or slowing down the planet's rotation. Ocean currents and atmospheric winds also shift mass, affecting day length. Even weather systems like El Niño can make a measurable difference. Another factor is the Chandler wobble, a small, irregular shift in Earth's axis, possibly linked to changes in the core and ocean pressure. The recent disappearance of this wobble may be connected to Earth's speed-up. Scientists are only beginning to unravel how these forces interact. The interplay of core, ocean, and atmosphere makes Earth's rotation a complex, dynamic system. For billions of years, the moon's gravity has acted as a brake, gradually slowing Earth's spin and lengthening our days. When dinosaurs roamed, a day was about 23 hours. 1.4 billion years ago, it was just 18 hours. To keep atomic time and Earth time in sync, we've added 27 leap seconds since 1972. But now, with Earth accelerating since 2020, the gap between atomic and Earth time is shrinking. The brakes are off, and for the first time, we might need to subtract time instead of adding it. This reversal upends everything we thought we knew about our planet's rotation. Scientists are scrambling to adapt our timekeeping systems to this new reality. The next leap in timekeeping could be historic. A millisecond may seem trivial, but our world runs on precise timing. GPS, the internet, financial markets, and power grids all depend on perfectly synchronized clocks. If Earth's rotation drifts from atomic time, GPS errors could misdirect you, and financial transactions could go awry. Even the internet's security protocols rely on accurate timestamps. Engineers must constantly adjust systems to keep digital and physical worlds aligned. Ignoring these tiny shifts would be like building on a shifting foundation. Eventually, things break. That's why tracking Earth's spin is vital for modern society. Milliseconds matter more than ever in our interconnected world. With Earth spinning faster, we may soon face a new challenge, the negative leap second. Instead of adding a second to our clocks, we'd have to skip one, something never done before. This could cause chaos for computer systems and networks unprepared for such a change. The debate is fierce. Some say we must follow the data, others warn of risks to critical infrastructure. The International Earth Rotation and Reference System Service is monitoring the situation closely. A negative leap second could be needed as early as 2029. The decision will have global implications for technology and timekeeping. It's a dramatic reminder of the tension between nature's unpredictability and our need for order. We're living through a scientific mystery. Earth has reversed a billion-year trend and is spinning faster. Theories abound, but no one knows for sure what's causing this acceleration. Scientists are watching closely to see if the predicted shortest day arrives this summer. The answer could reveal whether this is a short-term blip or a new long-term pattern. Understanding the link between the Chandler wobble, the core, and the spin rate is key. This story shows science in action, curiosity, discovery, and the thrill of the unknown. As the clock ticks,